Hello and welcome to How Do I BI, a many-part screencast series on the use of SQL Server Analysis Services 2008, which is a companion to my book Smart Business Intelligence Solutions with Microsoft SQL Server 2008. This is Lynn Langett. I'm a developer evangelist with Microsoft in Southern California. And in this edition, we're going to talk about how to implement OLAP cube aggregations using bids. Before we do that, we'll take a look at the FAQs and gotchas around aggregation implementation. And the first one is that zero aggregations are the default when you implement the default storage of MOLAP. Typically, you will want to use, as I've listed in this slide, some type of aggregation. And I'll demonstrate using the aggregation storage and design wizard inside of bids, which will help you to select the percentage of queries to optimize via aggregation or the storage space that you wish to allocate for aggregation. You can also use many advanced tuning mechanisms to further refine the aggregations that are associated with your particular partitions in your OLAP cube. So in the screencast, we'll take a look at the procedures around using the aggregate partition designer and the individual aggregate designer, which is new in Analysis Services 2008. The gotchas around aggregations are to not over-aggregate because as you may or may not know, aggregations are used by queries at different levels of dimensional hierarchies in addition to the level that the aggregate is actually placed. So in other words, if there's an aggregate at a lower level, it is very often used by a query at a higher level in a dimension. So for that reason, aggregating at a higher percentage of query optimization than 20 or 30% really results in no improvement in performance and some issues around cube processing because of the amount of aggregations that have to be calculated along with storage. So another consideration or a gotcha is to aggregate appropriately for the partition storage design. MOLAP partitions, or native multidimensional OLAP, require a lower level of aggregation because the source facts are stored in the MOLAP format, making queries very, very fast, even if they have to go all the way down to the source level. HOLAP, as a reminder, is hybrid, where the aggregations are stored in a multidimensional format and are queried relatively quickly. However, source facts are not copied. They are kept only in the source relational system. In the case of HOLAP, you might choose to define aggregations at a higher percentage in order to improve the performance of key queries. ROLAP creates the aggregations in the relational source, and in the case of ROLAP, you may again choose to define more aggregations than you would for MOLAP. The last gotcha is that dimensional aggregates must be designed correctly in order for aggregations to work. And in the previous screencast that I did on the proper setup of dimensions using bids, I explained the new attribute designer inside of attribute relationship designer inside of the dimension designer, which has been included in 2008 to help customers to be able to visualize and design the relationships in a way that supports effective aggregation. And there are also, of course, new AMO warnings, the blue squiggly lines, that show up throughout the cube, but in the case of aggregations, particularly in the attribute relationship designer, if those relationships have been either not set up at all and the data could reflect that, or set up incorrectly. So do not ignore those AMO warnings in your cubes when you are working with aggregates. And with that, we're going to go ahead and go over to the screencast and take a look at the procedure around designing aggregations. Screencast, we're examining how to use the aggregation design section of the OLAP cube designer in bids to implement aggregations for an OLAP cube. And as with previous screencasts, what I've done here is I've loaded the AdventureWorks sample, double-clicked on the cube, and then clicked on the aggregations tab in the cube designer. The first thing that we want to do is use this section to examine which aggregations have already been designed and associated with the partitions in the cube. If you're unfamiliar with the concept of partitions, you might see the previous screencast that relates to partition setup and usage. So in our particular cube, we have the partitions associated here with aggregation designs, and if we open them up, we can see that, for example, in internet sales, we have aggregations designed here, and there are 22 aggregations for the partition size in rows of 32,000 and such. And we can see that this group of partitions is included. So if I open this up, build dialog box up, we can see that the partitions are included for internet sales for 2001, 2002, 2003, 2004. If I wanted to associate a new type of aggregation, that's called an aggregation design globally, although you can do it more granularly, and I would assign that by selecting an aggregation design that I had already set up from the Assign Aggregation Design dialog box, and then clicking on the partition of interest to associate that aggregation design with that particular partition. I'm going to close out of this and just open up some more of these partition groups, such as internet orders, internet customers, and you'll see for quite a few of these there are 0 aggregations designed. And as I mentioned in the introduction to this screencast, the default in analysis services is to have 0 aggregations. And in fact, for some of the smaller cubes that I had designed in production, that was adequate in terms of query performance results. Adding aggregations does add to cube processing times and cube storage space. However, it does improve query performance times so long as the queries would be using the aggregations that you've designed. So if you wish to add new aggregations through bids, what you would want to do is click on the first button that's embedded in the aggregation designer called Design Aggregations, and that'll open up the Welcome Design Aggregation Wizard, and then just go to the next page of that, and then you would want to select the partition to modify from the particular group that you're working with. So I've got internet orders selected, and I have 4 partitions inside of there. So I'll select the first one, which is Internet Orders 2001. It shows me the source partitioning query and the storage mode, which is MOLAP, and then I'll click Next. In SQL Analysis Services 2008, we have a new capability in terms of aggregation usage design. In previous versions of the product, we simply included an algorithm to select aggregations to be created, and customers told us that they wanted to have a little bit more control over which values in dimensional hierarchies and dimensional attributes aggregations were created. So this review aggregation usage dialog page of the wizard is new, and you can see by default we have for each dimension and dimensional attribute the default aggregation setup, and we have the option to change that by clicking in the full column, which means aggregate everything, the none column, or the unrestricted column. Although this is a very powerful capability and you might be tempted to click full on key dimensional attributes and hierarchies, again, I would caution you, as I said in the gotchas, that you do not want to over aggregate your cubes, because that will result in excessively long cube processing times, storage times, without the corresponding improvement in query performance that you're looking for. So I'm just scrolling down to show the various objects that you can change here, and we're going to leave it at the default, and then I'm going to click Next. And the next dialog page here asks us to specify object counts, because in order to design partitions, one of the options that we have available is to design as a percentage to total objects. So the reason we have the ability to specify this is we may not want to have the overhead on the server to actually execute the count. So we can actually type the value in if we knew how many rows we had, or we can click Count, and it will go ahead and count all the rows in our particular selected object. In this case, we had an estimated count of over 60,000 and 1,000 in the partition. So then we're going to click Next, and we are in the Set Aggregation Options dialog box of this wizard, and we have a couple of different options here. We can ask this to design aggregations until the estimated storage reaches a certain size, or until the performance gain, and this would be of query results, reaches a certain percentage. If you're feeling very powerful, until you click Stop, or Do Not Design Aggregations. Now I'm going to click on until estimated storage reaches 100 megabytes, and you can of course say gigabytes as well. Click Start, and this is actually going to take a couple of seconds, because what it's doing here is it's analyzing the structure of the cube in terms of the dimensions, the hierarchies, the levels, and figuring out, and using an internal algorithm, where cube performance can be best impacted by adding aggregations. Now, the thing that is being considered here is the structure of the cube. The thing that is not being considered is common query patterns. There's a different tool that we're going to look at a little bit later in this screencast that allows you to pass in a capture or a trace of common query patterns and then to request that the server design aggregations to optimize those queries. So I'm going to go ahead and click stop just because for the purposes of time we don't need to let this thing go on. And you can see that 8 aggregations have been designed. The optimization level is 9% and it shows the storage space. And now if I click next, I can give this aggregation design a name. And as I showed you when we started this screencast, this aggregation design could be assigned then to one or more partitions. So our options are to save the aggregations but do not process, or to process now. And I'm going to cancel out of this. And then I'm going to go to the next tool that is available to help you to design aggregations, which is the usage-based optimization wizard, and open that up, which is the tool that I was referring to while the previous tool was processing. And what this allows you to do is based on the partition that you select, and I'm in the dialog box asking us to select a partition from the group, so I'll select Internet Orders 2001 and click Next. Then I would specify query criteria for the wizard to use as a basis for creating an aggregation scheme. So the filter criteria that are available for me to select are the dates, beginning and ending date, the users, or the most frequent queries. Now you can see inside this dialog box we have a warning and it can't proceed because by default the overhead of capturing queries, or tracing if you will, is not enabled on analysis services because of the overhead that it entails. So it gives you the fix inside of here. The connection string cannot be found. Open the SQL Server Management Studio in Analysis Services Properties page. Check the value of the log /query log connection string. There are a couple more values that you need to configure to set this up, to turn this tracing on, to create this capture. Again, I've detailed that in my book, but once you have the capture, then you simply feed it into this wizard and then it will spit out aggregation designs based on the parameters that you specify. So I'm going to click cancel to go out of here. In addition to the aggregation designer and the usage-based optimization wizard, we have a new feature in SQL Server 2008 based on customer requests. And what that is the aggregation designer, so the manual aggregation designer. So right now we're looking at the standard view. If we click on the embedded button for the advanced view, what we then see is some dialog boxes where we can select a measure group. We could sort if we wanted to, and that's set to internet sales. And then we select an aggregation design, and we're going to select the one that's by default, which is called aggregation design. And then we have the ability to select a range. In our case, we have 0 through 21. So we'll then open up a dimension like promotion, and we'll see all the attributes that are associated with it. Across the top we have some label values, which are just showing us that we have aggregations associated with this particular attribute value. And for example, we're in promotion and promotion category. We have aggregations designed for A2, A3, so on and so forth. What this is the ability to design at a very granular level additional aggregations. We're just viewing them here. You'll notice that when we switch to the advanced view, we then have the ability to create a new aggregation design and a new aggregation. So if we click on that, then we can just go inside of here and we can then create a new aggregation design by clicking that button on the embedded toolbar. We can create a new one, or we can copy it. So again, very, very granular, and this was at customer request so that aggregations could be designed very specifically. What I've found in real world practice, I'm going to go ahead and set this back to the default, however, though, is that if you effectively use storage partitioning and usage-based optimization, and you verify and validate any custom MDX queries that are being sent to the SSAS cubes, you will probably not have a large amount of use for the advanced view of aggregation design. This is for probably the largest level enterprise customers. So unlike a relational query tuning, where you've spent probably quite a bit of time manually tuning indexes and so on and so forth, if your cube is properly designed, if your queries are constructed with the most optimal MDX, you probably will be able to just simply use usage-based optimization with the appropriate filters, and your aggregation should result in queries that perform well for you. So this is the aggregation designer in BIDS.